In the previous discussion, we have stopped with the importance of software engineering. So in today's discussion, we will be seeing the introduction to software engineering. So let's see the agenda of today's discussion. That is introduction to software engineering, the nature of the software. So moving in depth to the topics related to each agenda, the first one is the nature of the software. In this, we are going to cover the software definition, the software applications, legacy software. So moving firstly to software definition. So let us see the comprehensive IEEE standard definition that states the application of a systematic, disciplined, quantifiable approach of the development, operation and maintenance of the software. So in the definition, if we see the term called quantifiable. Quantifiable is nothing but something that is measured in quantity. So the application of a systematic, that is a proper procedure that is being followed when you are trying to execute or accomplish a particular task. Disciplined, that is in a proper way it has to be executed. Quantifiable is nothing but it is measured in terms of the quantity relevant to that specific field. And these are the approaches to the development, operation and the maintenance of the software. So moving further, we have the definition in general of software. So what is a software? So we can see instructions or computer programs that when executed provide desired features, function and performance. So when we have say computer programs, in the introduction section we have seen what are computer programs, or we can state computer programs as set of instructions. And it is saying that when we executed provide desired features. So when you say features, it is nothing but the simplicity, the modularity, the stability, the accessibility, design, clarity, and efficiency. So these are the listed features that are attained by the software. So moving to the next section, that is the data structures. So these data structures will enable the programs to adequately manipulate the information. So what do you mean by adequately manipulating the information? So we have lots of data, let it be large sets, small sets. We try to manipulate that information, try to change that information basing upon the tasks that we have got or the proper way that it should be documented in. So what are the data structures? You can say the data structures are the particular way of organizing the data in the computer. So we have so many data structures, right? So presently Python uses the list, the tuples, all these things. So these are different kinds of data structures in which you try to fit in the data and work it on a computer. So next, if you see the descriptive information in both hard copy and the virtual forms that describe the operation and the use of the programs. So it is stating that, the third point is stating that it also elaborates the descriptive information that is in both the forms, that is the virtual as well as the documented copy, which is trying to elaborate on various operations and the use of the programs. So moving further, we have I have a small discussion on what are software types. We have two types of softwares, that one is the system software and the other one is the application software. So looking at the first one, that is the system software, it supports the use in the computer operations. Whereas application software, it concerns problem solving and the use of a computer as tools. So when you say system software, it is nothing but it is trying to make the system operate, or it is trying to support the usage of the system. And this, coming to application software, it is executed by using some specific tools. So tools can be actually elaborated in the form of the source code editors, the compilers, or the interpreters that we have. So nowadays we have a lot of tools that are online. So whatever is our task that has to be executed, you can use so many tools. As the technology is advanced because of this COVID, most of the things have become virtual, and every field, every section you can take, there are different tools that have been come out, and we have also have online tools which are helping out the people to reduce the space on their system so that we can work online on the online editors and all these things. So this is the first one. Coming to the second one, it says it's managing computer machine resources like the registers, the CPUs, the IO systems. That is, it is trying to have a focus on the resources that are there in the system. And when you come to application software, they completely manage operations, like trying to completely focus on the data, like sorting the data, updating them, inserting and deleting. Inserting is like adding some data. Delete is like removing it from the operations or the programs that we execute, or updating, trying to fit in to the existing data structures, or sorting, trying to arrange them in a proper order. Next, coming to the third category, that is the low-level languages. It is written, system softwares are written in low-level languages. As you can see, the assembly language. As you can see, the assembly language. And coming to the application software, it is written in the high-level languages. So if you are looking at the third point, what are low-level languages? You can state low-level languages. It's a combination of assembly language plus the machine languages. And we can also say that it is having little or no abstraction from the computer's instruction set architecture. But when you come to the high-level languages, it is having a strong abstraction from the details of the computer. So what is this term saying? Abstraction. That is, the low-level languages is having no abstraction, and high-level languages is having a strong abstraction. That is, we don't focus much on the internal details. So if you're not focusing much on the internal details, it is like the low-level languages that goes with the assembly level and the machine level languages. But when you see high-level languages, it is having a strong abstraction, which says that you are trying to focus on the internal stuff, the internal coding, and trying to work out. So you can see the examples like the Pascal, the C++, VB, Java, Python, and whatnot. So many languages have come out every now and then. You see, today we have a language, and tomorrow we have another different languages coming up with different versions also, different releases of the versions. Right? Next, coming to the next one, that is used as long as computer is turned on. That is, the system software works until the system is turned on, and use only when it is needed. That is, application softwares are used only when it is needed. Suppose you want to use different applications, like you want to work out on Excel, you want to work out on Word documents, or you want to download something specific related, you want to play games. So then and there you download, and you will use it only when it is needed. All the time you don't require to use the application software. It means that. So moving to the next one, that is it performs more than one job or a task or a process, which is called multitasking. But here, when you come to application software, it is only performing one job at a time. For example, you can say multitasking is nothing but you're trying to have different processes running parallelly or working together. But when you come to application software, only one job or a task is nothing but when you are opening some kind of applications, you can't run all those applications at one go, right? Suppose you might think when you are opening a system in different windows, you can do it, but only when you are minimizing the things, you can work out on the other applications. It means that. Now coming to the last difference, you can see it controls many processes at a time because it is multitasking. And Here, process done by the following step by step, meaning each process is done one after the other. So these are the things you can say that brings a broad categorization of the system and the application software. Moving to the software characteristics. Moving to software characteristics, we can say that software is designed or engineered. It is not manufactured in a classical sense. So what does that mean? The first point, software is developed or engineered. It is not manufactured in a classical sense, meaning you are trying to get in all the things and you're trying to working on it and you're trying to develop a software, but we are not trying to manufacture it as we do for the hardware products. Similarities exist between both these things, that is the software and the hardware manufacturing. So there are three things that I have stated here. The first one, if you can see, is the high quality and the design. That is, both these activities, that is the development and also the hardware manufacturing, are common. These both are common for both these activities. That is, if you are having a high quality, then you will produce a good design. If there is a high quality, obviously there will be the result in the good design. But when you come to the manufacturing phase, when it concerns with the hardware, it is like you have quality problems when you talk about the hardware. But when you come to software, generally non-existence, meaning we have stated that software is developed but not manufactured. So we are specifying that as non-existent. And both these activities, that is the software development and the hardware manufacturing, are dependent on the people, how they sort out the things, how they try to get better results. And finally, we can say that work accomplished among people is entirely different. So moving further, continuation of the software characteristics, we can say that software doesn't wear out. So what do you mean by software doesn't wear out? So the figure that you can see over here is talking about the failure rate and the time, which is the time is on the horizontal path, that is the x-axis we can consider, and the failure rate is on the vertical phase. You can consider it in that manner. You have a bathtub kind of a curve, which is stating that failure rate as a function of time for hardware. Right? So this is a bathtub curve kind of a figure, which says for bathtub curve, which is having high failure in the early stages. And if you are having if you have found out the defects and you're trying to correct it, you can stop it at the early stages. That is, it becomes steady at the early stages. The errors can be, if the errors are detected, then we can sort out the things at the early stages itself. But as the time passes, then we say it is being wear out. We use the term wear out. That is, as the time passes, it is affected and the hardware begins to wear out. So this particular diagram is talking about the failure curve of the hardware. That is, initial stages will be fine, and when the time passes, you will be coming across different errors. If you are correcting those errors, trying to remove the defects, then you will be making the steady level of the hardware. Else, as the time passes, it wears out. So moving to the next category, that is the failure curve for software. Previously, we have seen the failure curve for a hardware. So now if you can look at the diagram, again, it is the focus on the time to the failure rate. So if you look at the first point, that is the failure rate takes the form of an idealized curve. That is, you had a bathtub curve for the failure rate for hardware. Here you have an idealized curve, if you can observe. And initially you will be having undiscovered threats in the early stages. So once you are trying to sort out those threats, you will be correcting those threats and make the curve flatten a bit. That you can see in the diagram. So initially it was an idealized curve. Once you are discovering the threats at the early stages, as time passes, when you are trying to correct them, the curve flattens. You can see in the diagram, change the actual curve, increase the failure rate due to side effects, and again it comes down and becomes normal once when you are trying to remove the errors. And we generally say that hardware wears out the spare parts, meaning we will have spare parts for when hardware is out, hardware is damaged. But for the software wear out, we have to correct the design errors. And we can also state that the industry is moving forward to component-based construction, and it is trying to become custom built. That's the third characteristics. So moving further, the next things that we're going to discuss is the software application domains. In the software application domains, it's divided into 7 broad categories. The first one is the system software. As we have seen the differences between the system software and the application software, as it's one of the broad characteristics, just a brief notions of all these things again. Collection of programs written to service the other programs. Before I proceed to this elaboration of system software, you can see that image that is comprising of the symbol that is showing Windows and the iOS, the Android, and the Linux. So when you look at all these things, it is like the operating systems it is defining the operating system. So in general, we can say that system softwares are none other than the operating systems. So you can say that collection of programs written to service the other programs. So here we know Windows, and we have latest version of the Windows, the releases, and we have the iOS, and then we have Android, and then the last symbol is indicating the Linux kernel. The Linux kernel, which is acting as an open source Unix like the operating system. And if we talk about Windows, we can say the latest version is the 11th version, and the version is 21H2, you can say. Next, we also have something called embedded devices. We have something called embedded devices, whose version is about, it is Windows 10, and version is 21H2. So like that, whatever operating systems come and go, they have their own latest versions that are coming into existence. So moving to the next category, that is like the compilers, editors, and the file management utilities. So what is it saying? We have the first thing it says, like, you're trying to service the other programs, and it is focusing on the operating systems. And then we have compilers, editors, file managements, where we are trying to work out our code on, or trying to focus on some file management utilities. And moving to the next point, which says generally system software are involved in complex processes. That is, they have to execute by involving in different kinds of complex stuff. Next, system applications like the operating system components, meaning all these are included in the system software. Then you have the drivers, the networking softwares, which tries to focus upon the networking, the telecommunication processors, and we also largely focus or largely process the interdeterminate data. And we have a heavy interaction between the system software area, because you are trying to interact. That is networking, as I have said. Next, we have the involvement of a lot of multiple users and the computer hardware. And lastly, we focus on the concurrent operations also, that requires scheduling and resource sharing. So concurrent operations will have scheduling and the resource sharing. How do you try to share the data, and how do you try to retrieve the resources, and how do you perform concurrent operations? And lastly, you have complex data structures that are involved with the system software. So moving to the continuation of the software application domains, if you can look at the figure over here, what does this depict? it is trying to talk about the application software, which is the second broad category of the 7 things that I have said. So it is like application software. You can see on the screen, you have a WhatsApp, you have a YouTube, you have the Angry Birds, and then you have different kinds of symbols, Netflix, Twitter. All these are called the application software, which makes the second categorization. So they are actually called the standalone programs that solve a specific business need. Standalone programs, that is trying to talk about in terms of independent programs. And then these have their own specific tools for their own businesses and the technical data. It focuses on the technical decision making. Then moving further, it actually controls the real-time businesses and then also focuses on point of sale transaction. That is how you are trying to do day by day transaction, or how you are intact with every process that is being done. That is business related processes. And also in the real time manufacturing process control. So moving further to the next part, that is the engineering scientific software. So when you say engineering and scientific software, it is like you are trying to have applications that will start from the astronomy to the volcano. So what do you mean by astronomy to the volcanoes? That is, the applications are ranging from the spaces and all the things. Next, from automotive stress analysis to space shuttle orbital dynamics. That is completely related to the space, the automotive, the automobiles, and all these things. Next, from the biology, or you can say microbiology, to the automated manufacturing which is involved in various things. Next, you have applications within engineering and scientific area. So all these, for every field that you take, each field have their own softwares. So these points depict that every field that is being stated here is trying to have their own specific softwares. And you're trying to move away from the conventional numerical algorithms and completely focusing on the system simulation. So when we said simulation, what is simulation? It is nothing but the process of modeling something in the real phenomenon with a set of mathematical formulas. I repeat, simulation is nothing but, or simulation software is nothing but the process of modeling real phenomenon with set of mathematical formulas. So let us have a small image of how a simulation software looks like. Here, like this, you have lot of simulation softwares. This is nothing but, it is trying to, it's a kind of a factory where it is factory outlet, or which is trying to arrange all the catalogs in a proper way. So it is trying to help you out build a factory, or you can try to assume some school building or a college building, or you're trying to assume a bus and how many seating it has. All those things are done by simulation. So every field has its own simulation softwares. So this is an example where you can arrange the peoples like this by just using the relevant softwares and trying to add the things that you want in the fields, specify their values, and all those things that you can see in the image over here. Right. Moving to the next part, that is the embedded software. So what is this embedded software? Right. It is nothing but the computer software. It is nothing but the computer software written to control machines. It is nothing but the computer software that is trying to control the machines. It is trying to control the machines. And it is specialized, not typically the computers. So I repeat, embedded softwares. So I repeat, embedded software is nothing but the computer software written to control machines, and they are not actually computers. So they are specialized for hardware that it runs on, and it also has time and memory. So moving, it resides within a product or a system. It resides within a product or a system. It is used to implement and control features and functions for the end user and the system itself. So what is it trying to say? It is trying to say that within a product, you are having this particular software. And it is used to implement and control the features, right? So implement and control the features, if you're trying to operate something, right? Internally built features are existing, and it is done with the help of a embedded software. And it is limited and exotic function. It can perform limited and exotic, that is few functions in general, like keypad control for a microwave oven, right? We try to place whatever stuff we want in a microwave oven, and then you try to give it some you press whatever you want to do on the keypad that is available on your microwave oven. So that is one of the example of the embedded systems. And then you have digital functions in an automobiles, and you have fuel controls, you have dashboard displays, you have the braking systems. Nowadays all the cars are also having all these things, right? All these are having embedded softwares. So moving to a brief view of how the embedded software actually looks. You can have a look at the first one, that is the anti-lock brake, right? We see it in our cars as well. The traffic control, how is it able to monitor the traffic? And the camera autofocus, how is a camera able to focus on the faces or any device that you take? And the washing machine functionality, it you just set some time and it completely works for you. And the aviation controls, like you get the information even though like the land or on the land or in the air. So all these are having the embedded softwares within them. And you can see, look at the first one, which says act similar to an OS on a computer. Like the system doesn't work with an operating system. When you say if you want to execute some functionality, if you don't have this embedded software, you cannot check out for that output. That if you don't have this embedded things, what was there before this latest washing machines? You have to just drop in all the clothes and then drain all the water, and then you have to actually dry all those things. But now everything is automatic. That is with the help of the embedded software. Next, it also performs high level functions for any device, for a specific device. And it does not depend on any kind of a hardware. It means that you don't have to require a hardware beside the original device so that it actually functions. So the third one says it does not require any hardware. And finally, it also says that typically will have user or system interaction. What is this user or system interaction? It requires an user or a system interaction. That is, if you don't go and press a button on the washing machine, it does not start. Nor if you take an oven, if you don't give the functionalities to it, or you don't give the indication to it, if you don't give commands to it, it will not start. So it means that, right? All these are the base examples that all of us know. So it gives us a clear picture of what an embedded software is. Moving to the next one, that is the product line software. So what is this product line software? It is designed to provide specific capabilities for the use of many different customers. Meaning you have various customers and all of them has a proper design, or it is execution. Or I can say it as defined to provide a specific capabilities for use by many different customers. And next you can see can focus on limited or esoteric marketplace, meaning less or small marketplaces. And then you like the inventory control products, like examples like inventory control, the catalogs, the storage, or some storehouses, or address mass consumer markets, right? And like the supermarkets, or like word processing, spreadsheets, different kinds of computer graphics. So all these are the product line softwares which are designed to provide a specific capability for different customers, right? It's like trying to generate a template which is being used by many people. You don't have to sit and design some specific template for a work. It is like you have a template already defined and many people try to use that so that their work becomes a bit easy. And you also use them in the multimedia, entertainment, and the database management system. We all of us know multimedia that involves video, audio, holograms, and various other things. And entertainment, all of us know it, and database management system, which handles data, how it has to be stored, how it has to be inserted, and different things working upon it. And finally, you have personal and business financial applications also use this product line software, so that you don't have to sit and create all the different things. If you have a template right ready, all the financial applications can also be done at ease. So looking at a small example, if you consider an online shopping, you have two ways over here. One is the catalogs, and then you have the buy parts. So when you say catalogs, you're trying to search for some particular item. If you have an information about that particular article within that catalog, that is, if you know some specific number or all those things, then you can do it. If you don't have that, you have another phase of buying the things, that is shipping options or payment options like this. And again, when you look at article information over here, you have custom fields and the article type, and you also have shipping operations, which requires the electronic goods, the physical goods, and the services, all these things. And coming again to the shipping, you have the carrier section, quality of service, and shipping cost calculations. Payment are the credit card and the purchase order. So what is this trying to tell us? If you just go back to product line, what is it saying? It is trying to provide a specific capability for use for many different customers, right? So when you say online shopping, I have chose this option because all of us do every now and then. That is the online shopping. So it is trying to segregate into two things, that is the catalog and the buy part. So this catalog is trying to speak about in terms of article information and searching. If you see something in the dark, just have a look at the things that are there. That is, complete O is optional, and then you have it is mandatory, and this particular symbol goes with OR, and a blank symbol goes with XO or activity. So when you say catalog, so for online shopping, it is mandatory that you have a catalog and the buy parts. And then if you want to search something, if you know the article information, then it is kept mandatory, right? And you don't have, searching is optional, because every user does not require to have the exact information about that article, right? So we keep searching. So when you are trying to search, it is like it's an optional case. Coming to the buy parts, then shipping options are actually considered as optional, because you have so many things asked. So whatever suits to that particular user, he tries to opt in, select his relevant things. Next, the payment options. Payment options is obviously mandatory. If you want to buy something, obviously you have to pay. But they have options like you can use a credit card or some kind of purchase orders. Nowadays we have got lots of cards. You can use all those cards. So that is why he had given an OR for the payment option. Then again, coming back to the article information, which is talking about the custom field and the article type. And for the custom field, it is like it is optional, and article type, it is mandatory. So whenever you are trying to give the information about that particular article, you have to focus on the type of that article, so that your search becomes more easy. So then coming to the article type, you have an options which specify electronic goods, physical goods, and the services. What you want to choose is up to the user. So this talks about the product line softwares, which is designed to provide a specific capability for use by many different customers. So every section you have this product line softwares, where you don't have new softwares for every small task that you are doing. You will have product line softwares which will benefit the same things in different ways, you can say. So moving to the next category, that is the web applications. So all of us know, in short, we say apps, which are nothing but the web applications. If you are looking at the first point, that is called the web apps, and it is network-centric software category. So what is this network-centric? Network-centric is nothing but whenever you say network, then the client-server architecture comes into the existence. So who are the clients and who are the servers? Client is a user and the server is from where he can retrieve the data asked by the user. And you have a wide area of applications in the web, right? And there few things are linked to the hypertext files. The first one you can say linked to the hypertext files. That is, whenever you are opening a website, yes, for example, let us take our college website. When you open the website, you have a lot of things that you see, right? The obviously the videos, and then you have the information about the college and all these things. So when you're just clicking on the college information, again, you have a drop down. And in that drop down list, you may have different courses. And then when you go to click on the courses, it takes you to another page. So all these are nothing but the links, the hypertext links, you can say. And moving to the next one, you have present information using text and limited graphics, right? Web applications will involve information that has proper text and limited graphics. And you can also say that you have various web versions evolving every now and then. And it not only provides the standalone features, that is, it not only focuses on its individual features, it also has various computing functions and the contents to the that it produces to the end user, we can say. And also integrated with corporate databases. That is, when you say web applications, we are trying to design by using various codes in the software, trying to develop a application and trying to merge that with even the corporate databases, as it said, that also performs various business applications. Moving to the next one, that is the artificial intelligence software. So when we say artificial intelligence software, the first point that it states is makes use of non-numerical data. What is this non-numerical data? That is, the name itself is saying non-numerical. That is, we are not using any kind of numbers, but you are trying to know about some kind of actions. If you say tasty food, or if you're saying bright colors, great colors, all these things, like you are trying to focus on those features. Okay. The first point that states is the use of non-numerical data. So it is trying to make the machine think and make it learn eventually. That is, you are trying to train a machine basing upon the features that a human sees, and you're trying to train that particular system. That is, it is trying to learn by itself. Non-numeric is nothing but it is trying to learn by itself. And they form the specific algorithms. And secondly, you can say that this non-numerical algorithms are observed and not measured. What do you mean by they are observed and not measured? Observed and not measured. So non-numerical data are observed and not measured. It means that, as we told you, non-numerical algorithms, you don't have a focus on trying to do all the calculations. Only you are trying to make the machine learn the features that it is there. Okay, like suppose if I say smell of a flower, or some kind of taste of a candy, or greatness of a person, you are trying to train that machine. So these are done with the artificial intelligence softwares. Next, and one more thing about this non-numerical is they are also called as data in this algorithms is categorical, meaning you divide them into various categories. So it is called as categorical and qualitative. Qualitative. It means that you are trying to specify them in proper categories and specify its quality, like it's a great person, all these things. And you will also have a yes or no. So all these understandings are called non-numerical algorithms, and you are trying to feed this information to the system that we are talking about. So moving to the next one, to solve all these complex problems that are amenable to computation or straightforward analysis. Or straightforward analysis. So, whatever I have said, non-numerical algorithms, they are trying to solve various complex problems which are focused on the straightforward analysis. And moving to the examples or applications that goes with this artificial intelligence software is that robotics, expert systems, pattern recognitions, ANN, theory proving, and game playing. So all these things, all these fields use non-numerical algorithms. So if you have a look at this particular picture over here, the first thing, all these are some examples of AI softwares. So the first one is the brain inspired artificial intelligence projects. And then you have chatbot platforms. So this chatbot platforms are nothing but the software that simulates human-like conversations with users via the text and messages. So what does this chatbot do? So this chatbot is nothing but a software that is trying to simulate human-like conversations, like how does a human talk, all that it tries to capture, and it is trying to send text or messages. If you have observed, if you are trying to book a course online, or if you have filled an online application form, so the moment you fill, or if you have done some kind of a payment, you get a message saying that you have got so and so. All those are actually some examples of chatbot. So they are the softwares that is trying to simulate human-like conversations and trying to send them in the form of text or messages. And then you have the third one, that is the NLP, that is natural language processing. What is this natural language processing trying to focus about? It is making the computers understand the text, the spoken words, same as humans do. So you are trying this particular AI NLP, or you can say NLP AI. It is trying to make the computers understand the text or the spoken words as the humans do, or same as the humans work. And the next one are the predictive analysis and prescriptive analytic software, completely focusing on the data. And then we have data mining softwares, another example for artificial intelligence software, which is trying to bring out knowledgeable data from the large sets of data. And we also have ANN, which is elaborated as artificial neural network software that tries to learn on its own, trying to learn the information. It is this particular computing is trying to learn the things on its own, and we specify them in terms of neurons, their added weights to it, and how you can bring out the individual details. So it is a software that is trying to learn the information provided by the system on its own. And then we have other AI platforms. You have data analytics software, which is trying to give us the data. Yes, for example, if you are trying to fetch lots of data, right? For example, we are seeing this data given and how many views we have got. That is with the help of the tools that are involved or this particular software. And also you have text analytics software, which has a complete focus on the texts. So moving further, we have something called software that is involving new categories. So in that, it is segregated into three types. The first one is the open world computing, and the second one is the net sourcing, and the third one is the open source. So these are the new challenges when you are talking about software engineering in depth. So what is this open world computing? This open world computing completely focuses on the wireless networking, which is used for distributed computing. And the main challenge is that it is able to communicate across the globe, you can say. Next, coming to networking, it is again a computing engine that is acting as a content provider. That is the entire resources, data, all those things. And it is beneficial for the end user. And coming to open source softwares, it is nothing but the softwares that are available for free on the web. And the main trend is that the results in the distribution of the source code where many people contribute. It is that if they make it payable, we will not be able to use any kind of softwares that we teach our students in general, like C, C++, Java, Python. All these are available freely. So these are the new challenges that comes under the categories or new categories under the software. That is the open world computing, the net sourcing, and the open source softwares. So moving further, we come to the next topic, that is the software engineering layers. So this software engineering is called a layered technology. Layered technology meaning it is having different phases, right? So first let me show you what is exactly tells us about. These layers include the tools, the methods, the process, and the quality focus. So initially, we need to focus on the tools, the methods, the process, and have to have a focus on the quality. So this is software engineering is called a layered technology. And the first point, if you see, the bedrock that supports software engineering is the quality focus, meaning the good the quality is, more the software sustains, you can say. Next, in the process layer. Process layer is acting as a foundation, meaning you are supposed to define the processes and how it has to be done, how the sequence has to go on. So that is acting as a foundation layer. And this software engineering process, it is trying to bind various technology layers. And then it also enables rational and timely development of computer software. So this is trying to keep upon the check of the softwares. How good is it? Is it working properly or not? And then trying to change as the time passes if there are any kind of flaws and all these things. So moving further, the layers, how the things, that is whatever I have shown you over here, tools, methods, process, and quality focus, how do they work upon? Looking at the first point over here, software engineering methods provide technical how-tos for building a software. So what do you mean by technical how-tos? Meaning how you have to execute different software engineering methods. Meaning how do you do it to make a perfect software? For that, you have to define methods which will have broad array of tasks involved. Meaning the methods you define, they will be helpful to elaborate on the wide range of tasks. Those tasks include communication, requirement analysis, design modeling or modeling a particular design, or whenever you're trying to construct a program, in the testing phases and the support teams. So all these things will have their specific methodologies which will be able to result in the involvement of wide range of tasks. So moving to the basic principles of the software engineering, it is like you are trying to have a focus or govern each area of the technology. And then it also uses various modeling activities and the descriptive techniques. Moving further, you have tools. What are these tools and what do they provide? They're trying to provide automated and self-automated support for the process. As I have told you, we have various tools existing that helps us to execute our tasks. And when tools are integrated, what does it happen? It is created by one tool and it can be used by another. That is, these tools are giving us the results, are resulting the things at ease, and the tools are integrated. Why are they integrated? So that the information created by one tool can be used by another. And then a system for the support of the software development. It is called the computer aided, meaning it is completely involving the system features, you can say. And the next topic is the legacy software. So what is this legacy software? It is saying that initially we have seen the 7 broad applications in the legacy. We have seen the 7 broad categories just before. So out of these, you can say that we can have some focus on the state of art software. Meaning, state of art software, it is trying to focus upon the specific tasks taken by the user and their relevant softwares that they have. So state of art software, they just released to individuals industry, meaning every specific individual or an industry or a government, all these people have their own software, it means to say. But generally, when you say legacy softwares, they are the older programs, that is the older versions of the existing software. Sometimes they are generally developed decades ago as specified here and have been continuously modified to meet the challenges. Obviously, every software is not same today or tomorrow. Every time it changes, different releases, different versions are being released. So why are these versions being released? It's just because the requirements of the user will change. The business requirements are changing. The clients require different outputs or different executions and all these things. So that is why you have to meet the requirements of the customer to satisfy him or for the end user. For all those things, it has to be changed, keeping on changing, right? And so this person named Liu and his colleagues have stated that many legacy systems remain supportive to core business functions and indispensable to the business. So what is he saying? So the main notion of what is this legacy software is that they are older softwares. They don't come into the existence. No, it is wrong. You are trying to develop new things by looking at the older programs or older softwares, trying to improvise them. If you don't have these legacy softwares, you cannot have a complete focus on the new things that you are building. So this person named Liu and his colleagues in the year 98. So he said that many legacy systems remain supportive. You should not think that they are burdensome, they don't solve various things and all. So he says that they still remain supportive to major core business functions even today. And they are categorized based upon the longevity and the business criticality. Suppose if any task is given to you and we are not able to monitor it on a proper way, or you don't have a focus on that particular area, then we come search these legacy softwares which help us to build at least 2 to 5 units, or at least try to help us build a structure out a new software, we can say. So this ends the discussion, the introduction to software engineering. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.